Hello everyone. Today we're going to talk about 2025 AMC 12.8, number 14. So the problem goes, points F, G, and H are collinear, with G between F and H. The ellipse with foci G and H is internally tangent to the ellipse with foci F and G, as shown. The two ellipses have the same eccentricity, and the ratio of their areas is 2025. So the eccentricity is just C over A. What is E? So just as review, in any ellipse, the semi-major axis is A, semi-minor axis is B, and C is the distance from the focus to the center. So, okay, let's see what this means, right? So we're told the ratio of the areas is 2025. The area of an ellipse is just pi AB, where A is this and B is this. You can see this because, yeah, like it's just a circle with radius B, which has area pi B squared, scaled by a factor of A over B, so pi of AB. Like you can think of an ellipse as a stretched circle. So yeah, so this will be our formula. So if the ratio of like the first ellipse to second ellipse is 45 squared, so 2025 is 45 squared, then that means because the ellipses are similar, that A over A1 is just 45. So A1 is going to be like the smaller ellipse, semi-major axis, and we can let B1 be the semi-minor axis of the smaller ellipse. So, well, okay, A2 over, yeah. So, this means that, well, okay, so, yeah, how do we know they're similar? Well, the two ellipses have the same eccentricity. So if C over A is constant, then that means B over A is constant as well. Because the definition of an ellipse is the sum of the distances from the two foci to any point on the ellipse is a constant. So in particular, this is true for this point, the co-vertex. So this is A because okay, so if we take F1 and F2, then and we take point P, then PF1 plus PF2, oh, sorry, it's just an alarm. So PF1 plus PF2 is a constant, and this is the focal length constant of the ellipse. So that's 2a. This is 2a because if we add this plus this, by symmetry, PF1 is just the same as QF2. So this part is the same as this part. But now this is just the total major axis of the ellipse, which is PQ. And since A is half the major axis, this is just 2A. Now if we take our definition, our focal length definition, and take the co-vertex J, then by definition, JF1 plus JF2 is constant. So that constant must also be 2A. Since the ellipse is symmetric, both of these must therefore be A. So JF1 plus JF2 are both A. Okay, so that means that since this is B and this is C, C squared equals B squared plus A squared. Or the other way around, A squared is B, A squared equals B squared plus C squared. So, okay, so that means if C over A is a constant, then B over A is also a constant, because like yeah, these are similar right triangles. So in particular, C is square root of A squared plus B squared. So yeah, if the eccentricity, yeah, if the eccentricity is the same, then like the two ellipses are similar. Okay, so that means the ratio, so similar parts of similar figures are in the ratio of similitude. So that means if we take this point to be P, PH over PG is just the ratio of similitude, which is 1 over 45. So if PH to PG is 1 to 45, we can think about breaking up PG into 45 equal parts. And then this part is one part, and this is the other 44 parts. So GH is 44 PH. By symmetry, the center of the small ellipse, let's call it C, this cuts the 44 parts into two parts of 22 each. So, yeah, so now we can just apply our focal length definition. So this is x, this is 22x, and this is 22x. Now, you know, it looks like A is 23x, so this is 23x. But that's exactly what we're looking for. We're looking for C over A in the small ellipse, or in either one of the ellipses. So sorry, this is A and this is C. So yeah, so that means the eccentricity is just 22 over 23, just B.